Okay, hello. So today we're going to be looking at the solutions of a triangle. So we're going to try to make this chapter as short as possible. Okay, so now when we say solutions of a triangle, let's consider now a triangle ABC. You see, we consider triangle ABC. Now, when we say solutions of a triangle, for a triangle to be said to be solved, we should have all its angles known. So if I give you a triangle and I ask you to solve the triangle I'm trying to ask you, you should help me find what is A, what is B, what is C, and also the sides. All the sides should be known. Now, we're going to look at the cosine rule, and we're going to prove it, but for this case, there's no question, but after proving it, you're going to see what I'm trying to say. Now, in this case, we have a triangle ABC. Consider triangle ABC. Now, this is A, this is angle A, this is angle B, and this is angle C. And then now the side opposite B is small b, the side opposite angle A is small a, the side opposite C is small c. So we have these sides. So meaning the length here is C, the length here is A, the length here is B. Now we are going to start with cos A because you know the cosine rule. We are going to see it at the end, but hope by now. So we have cos A. Okay, what we want to prove at the end of this question is A squared is equals to B squared plus C squared minus 2BC cos A. So this is the cosine rule, and we want to prove it to see how it comes about. And for this case, we are going to prove this one because, of course, you know there is B squared is equals to A squared plus C squared minus 2AC cos B. And then we have C squared is equals to A squared plus B squared minus 2AB cos C. So this is C, this is cos C, this is B, this is cos B, this is A, this is cos A. And I've told you what A, B, and C mean. These are the sides opposite the respective angles. So A is the side opposite capital A, B is the side opposite capital B, C is the side opposite capital C. Okay, so now, so I say these are the three like equations or formulas in the cosine rule, and we are going to start by proving this. And a question can actually be asked and say that proving any triangle ABC, A squared is equals to B squared plus C squared minus 2BC cos A. Now for this question, we are going to actually be particularly finding cos A. So cos A is what we want to find. Now we are going to drop a perpendicular from here. We're going to drop a perpendicular is like 90 degrees. So we are at 90 degrees to AB. So we drop this perpendicular. So now for that case, I'm going to label this is C is the entire length. You see? Okay, so I'm going to I've dropped a perpendicular from C to AB. And now this perpendicular, I'm going to call it CD, like it's going to be coming from C to D. So I have to introduce here this point D. So the perpendicular is coming from C to D. And this is A. Now I have to let, because remember here I have the length from A to B, but I don't have the length from A to D. I don't have the length from C to D. So we are going to let. So I'm going to let the length AD be equals to X. So I'm going to let this be X. And since we're letting this be X, this is going to be, because this is this from here, but the entire thing is C. So this distance here is C minus X. Then now we are going to let CD, because when you look at this, there are two triangles, a triangle here, there's a triangle here, but this is the height of both the triangles. We're going to just let this be H for the purpose, because it's both the height of this triangle and also this triangle. So now we're going to start working out the question. I hope this makes sense. We drop a perpendicular from C to AB. Perpendicular, that means it's 90 degrees. The angle between these two lines is 90 degrees. And we've let AD be X. And we let CD be H, because it's the height of both of these. Now we've let this be. So if this is X, this is C minus X. Okay, now we are going to extract these two triangles out. And we're going to prove this. Then the rest I'll just display. So I'm going to pause the video, then I modify this diagram, then we go on. Okay, so now this is what we had. We had triangle ABC. Then we drop a perpendicular from angle C to the line AB, and then at D, like we call the point where the perpendicular is dropping D, then we let AD be X. So this is C minus X because the entire length of AB is C, and then we let this be H, and these are the sides. Now, since for this case I said we're applying the formula, the cosine rule for cos A, that is why you see we are going to start with this triangle. We're extracting out this triangle. So from that triangle, this is A. We're just extracting it out from there. This point is D. This point is C. This is H. This is X. And this is B. So since we know we want to find cos A as our, like in our final answers, we are going to first say cos A from here. SOHCAHTOA, from SOHCAHTOA, cos is going to be adjacent out of the hypotenuse. We're going to call this equation 1. Now, but when you look at the big triangle here, like this big triangle, we have A, B, C. We don't have X. So meaning we have to find out of eliminating this X. I don't know if it's making sense. We have to find out of eliminating this X because we said when we are looking at solutions of a triangle, we want to solve the triangle. But when you look at the regular triangle, it has sides A, B, and C. So X is not included in the sides. So we have to find out of eliminating this X. So now that leads us to, we have to use the Pythagoras theorem. Yeah, so we have cos A is X out of B. So as I've said in the original triangle, with the original triangle is something like this. We have, this is A, this is B, this is C, this is side C, side B, and side A. So when you look at the triangle, there's nothing like X, so we have to find out eliminating this X. So we have to generate other equations, and we eventually find out eliminating the X, this X, such that our final answer doesn't have any X. Now the first equation we can generate from here, we can use the Pythagoras theorem, which says a squared plus b squared is equals to c squared, and here this is x squared plus x squared plus h. We have x squared plus h squared is equals to b squared. Now from here we can make x squared the subject, so this is x squared is equals to b squared minus h squared. Now for the second part, we want to extract this second triangle, because we've extracted this. Now I want to extract the second triangle. So I'm going to pause this video, then when I play it, I'll have extracted this, and I'm going to extract it the way it is here. Or I think, let me just do it, though it's going to make the video a little longer, but okay. So here we have B, here we have C, and this is D, this is H, this is C minus X, this is A, so this is D. Okay, let me change the color because, so we have this is the triangle, so we can still apply the Pythagoras theorem. So this is h squared plus c minus x squared is equals to a squared. So here h squared is going to be a squared, and sorry I forgot to say, but we can call this equation 2. Labeling these equations makes it easier for you to follow up, and even for the person marking to see what you're doing. So this is equals to that. So h squared is going to be a squared minus, here I open this bracket, c squared minus 2cx plus x squared. So here we have finally h squared is going to be equals to a squared minus c squared plus 2cx minus x squared. So we're now, okay, we could call this equation 3, but it's not necessary. We can just come here and say we should substitute for h squared, because remember, even h squared is not needed. H squared is not there in our first expression. So here we had x out of b. Then here in trying to get an equation to eliminate x, again we have h squared, but b is okay because b is in the original triangle, but h is not in the original triangle. So in the process of trying to eliminate the x, we again introduced an h squared. So now from this second triangle, we want to first eliminate the h squared, then we shall go back to our original problem, which was x, eliminating the x, because we want to have a final equation with the cosine rule, not having anything like h or x. I hope it makes sense. So here we are going to substitute for h squared in equation 2. So here we have an equation for x squared, for h squared, but we want to substitute it into that. So from equation 2, we said x squared is equals to b squared minus h squared. So here we are to substitute for h squared. So this is x squared is equals to b squared minus h squared. We open the bracket. This is a squared minus c squared plus 2cx minus x squared. So here we get x squared is equal to b squared minus a squared plus c squared minus 2cx plus x squared. So this x squared can come this side. So we have x squared minus x squared is equals to b squared minus a squared plus c squared minus 2cx. So this is what we have. So we have 0 is equals to b squared minus a squared plus c squared minus 2cx. So now here, eventually, now we can bring 2cx this side, because the intention of this whole thing was to make x the subject such that we can eliminate x from here. So we bring it this side. So we have 2cx is equals to b squared minus a squared. And I think plus c squared. So this is what we have. So we can divide through by 2c, divide through by 2c. So we get x is equals to b squared minus a squared plus c squared out of 2c. So we have this is now our value of x. So we can just substitute this. So we substitute into equation 1. So we're going to substitute this x into this equation. Okay, now we're substituting this into equation 1. So we're going to have our initial equation 1 was cos A is equals to x out of b. So this is our x, that's what we have. We're going to have cos A is going to be equals to what is our x? Our x is b squared minus a squared plus c squared out of 2c divide by b. But of course, you know, when you have to divide by b, you get the reciprocal, so it's times 1 out of b. So we have cos A is equals to b squared minus a squared plus c squared out of 2bc. So we can cross multiply, put here, so we can cross multiply, so this becomes 2bc cos A is equals to b squared minus a squared plus c squared. So we can take the a this side and take this the other side, so this was going to be a squared is equals to b squared plus c squared minus 2bc cos A. So here we've literally proved the cosine rule. So another hint, maybe something I can talk about, is that the question can prove that b squared is equals to a squared plus c squared, or prove that c squared is equals to. So that's what we are going to look at, though we're not going to work out, just going to be showing, and then we can move on. But here, as you can see, for this specific question, we drop the perpendicular from c, because in this case we don't need c, we want to find cos A. That's why you see we cannot drop the perpendicular from cos A in this question, because we need the A for this. But actually, you could even have dropped a perpendicular from B and done the same thing. The main goal is that when you do the perpendicular from here, you have this triangle having A, that you now get out the cos A. You see, so if we wanted B, would have picked this triangle first and used it to get cos B. And if we wanted C, we could either drop a perpendicular from here or from here. And then, so I'm going to just show that in the, just displaying it, then we can move to the next thing. Okay, now let's move to the next example. But before we go, I wanted to hint something. Note that when we are choosing the first triangle to work with, or when we are choosing which side, because we could have put the x this side or this side, but note that we make sure that the side we let to be x is the side which has the angle we are working with. For this case, we are looking for cos A. So that's why you see the side with A is where we put x. Okay, now let's move to the next thing. So this is the cosine rule, but for another angle. This one is for angle B. So as I told you last time, so when you're dealing with angle B, we cannot drop the perpendicular from B, so we drop the perpendicular from this side, for example, and from A to this line BC, but we call that point D, we let it be D. Then we let this side be x, and as I told you, the side you let to be x is the side that has the angle you're looking for, in this case, which is B. So we let this side be B. And now remember that if this is capital A, this side is small a, as we say this is capital B, this is small b, this is angle C, this is small c. Then we let AD be h because it's the height. So this is 90 degrees, that's why these lines are perpendicular. And now the first triangle we pull out is this triangle that of the side we are working with, one with B. So we have pulled it out here, and these labelings help you because you see this point D is here D, then you look at A is here. So these help you to map out like what value is where. Sorry, they help you to map out what value is where. So the height is H, this side is C. So you get cos B is adjacent out of hypotenuse, which is x out of C. Then from the Pythagoras theorem, this is what we get. We make x squared the subject. Remember, here we have an x, but we want to eliminate the x because x is not part of the sides of the original triangle we had. So we want to eliminate x. And now the first thing we do here, we use Pythagoras theorem. We get x squared is equals to c squared minus h squared. We call this equation 2. Then we now extract our second equation. Still, we use the Pythagoras theorem. Then we make h squared the subject. Why? Because here in trying to eliminate x, we've again introduced another unknown h, which is not part of the original equation. So we use the second Pythagoras theorem. Then we make h the subject. Then we substitute this into this because we want to eliminate h. So in that process, we go through this, and that's the answer. So the one you can try out the one for angle C. So just do the perpendicular from here. You can even still use this same figure, but this time let this be x and this a minus x. Okay, so that is it. The one for C. So I guess we are done with the cosine rule, proving the cosine rule. Now we're going to look at the sine rule.